All right, here we go. We're going to do level 4. So it says given ABCD is a square. Well, square means that all angles will be 90 degrees and that all sides will be congruent. So I get all that information from this statement. Okay, that's useful. Next it says segment AC bisects angle BAD and angle BCD. In other words, it cuts these angles in half, making this a 45 right here and a 45 right here. This is also 45 and 45. So with this information, we already know that this side is congruent to this side, and this is a 45, 45, 90 triangle. So the thing that we're actually trying to prove in 45, 45, 90 triangles, which we have, side C is equal to side A and B times the square root of 2. So the way we're going to figure this out would be by using the Pythagorean theorem. Basically, this can be side A, this can be side B. A squared plus B squared equals C squared. So therefore, when you get to the bottom of it, C equals A or B times the square root of 2. All right, let's write the proof. We're going to start with the first statement. A, B, C, D is a square. How do we know this? It's given. Piece of cake. Okay. Second given. Segment AC bisects angle BAD and angle BCD. How do we know this? It's given. Okay. The fact that this is a square tells us that we have the four 90-degree angles, so we're going to go ahead and state that measure of angle DAB, measure of angle ABC, measure of angle BCD, and measure of angle CDA all equal 90 degrees. We know this as the definition of a square. So that's a pretty easy statement to make. Also, we know from a square that all of these sides will be congruent, because in squares all four sides are congruent. Therefore, segment AB is congruent to segment BC is congruent to segment CD is congruent to segment DA. We know this because, again, the definition of a square tells us this. So these are all facts we know by the fact that it's a square. Next, we know that AC bisects angle BAD and BCD. So that tells us that these are 45-degree angles. So we get to say that measure of angle BAC and measure of angle BCA both equal 45. We know this from the fact that segment AC bisects, which means to cut in half, angle BAD and angle BCD. Alright, so looking at what we need to prove. We proved that we have two 45-degree angles and a 90-degree angle, and we know that A equals B. So we need to prove that C is equal to A and B times the square root of 2. The way we'll do that is by setting up a Pythagorean theorem problem. So AB squared plus BC squared equals AC squared. We know this because in right triangles, the Pythagorean theorem is true, so Pythagorean, T-G-O-R-E-M, we know that we have the Pythagorean theorem. So if we go ahead and solve this Pythagorean theorem, we're going to end up with literally AC equals AB square root of 2 or BC square root of 2. So that can be our final statement. Remember, we're never actually doing the math work on these problems. We're really just tracing the logic. So, that being our result of solving the Pythagorean theorem, our justification for that step is PEMDAS. And that is the 45, 45, 90 proof using a square. Thank you.